Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's DevOps.com Roundtable, brought to you by Techstrong and the AI Infrastructure Alliance. My name is Cody J. Brown, the host of Techstrong Learning, and we have an exciting panel ahead. But before I let them take it away, I do just need to cover a couple of housekeeping notes. First, today's session is being recorded, so if you miss any of our discussion, maybe you'd like to rewatch or share with a friend, the on-demand recording will be made available shortly after we conclude our live session today. If you have any questions, comments, concerns, we do want you to send those into our chat box today. This is going to be more of a discussion, so we just want to keep it all in that chat box and keep this conversation rolling. Send in any questions you have throughout today's program, where you're joining from, or maybe what position you are in your organization. And as always, before we close out, we are giving away 4 $25 Amazon gift cards at the end of our program, so do stick around for the whole duration. All right, so I promised Lee and Mike I'd let them introduce our panel, so I'm going to kick that over to you, Lee.
Thank you, Cody. Well, we all have a mobile or cell phone in our pocket. The vehicles we drive are becoming increasingly autonomous. And with every visit to your doctor, the diagnostic tools and patient data your clinician can leverage improves. And we can consider all of these examples as edge computing environments. But what does it mean to bring AI models into this space? As Cody said, I'm Lee Baker from the AI Infrastructure Alliance. And in association with Mike Vizard of DevOps.com and Techstrong TV, we bring you today's webinar, AI at the Edge. Happily, I'm not alone in standing at the edge today to provide some perspective on what edge AI will look like now and in the future. So allow me to dive in and introduce the panels. So in no particular order, Nancy Shemwell from Trilogy Cloud Networks. Nancy, I wonder if you could give us a quick introduction of you and your role and how edge computing is impacting crop yield.
Sure. So my name is Nancy Shemwell. As Lee said, I'm the COO at Trilogy Networks. The Rural Cloud Initiative is a coalition of companies that we've pulled together to be able to provide edge infrastructure and applications in rural America or rural globally. We are not an ag tech company, but we happen to be focused right now on ag in that if you look at the IoT and the opportunity for AI and machine learning to have a great impact on industry, one of the industries that can have great economic and commercial results is to automate the farm, right? There are labor challenges, there are increasing costs, and there's a global demand for increasing food supply, which actually is going to be critical over the next 30 years. So if you look at the automation of the farm, you can do a number of things today using cell phones, right? But if you want to start to take a look at all of that different information that comes down the pike, a farmer would say to me, or a grower, look, I use my head, I use my gut, but with all this data, at some point, somebody should be able to write something that helps me crystallize data from multiple points so I can make actionable decisions. So edge is what's going to allow those applications to work, and AI is going to provide the synthesis of that data for actions. And that's what the world that we're living in.
Thank you, Nancy. And I think we're gonna revisit some of those themes in this conversation. But thanks for the introduction, Daniel. If I go to you next, so Daniel Warner is the CEO of LGN. Daniel, tell me how edge impacts your world and kind of your function therein.
Yeah, I mean, LGN is a edge AI specific business, so we're fairly related to the world of edge AI. Maybe a quick story of why the business is called LGN. People seem to find that quite interesting. LGN stands for the lateral geniculate nucleus, and it's a part of our brain that focuses our attention on high value pieces of information that are out there in the world. And so we ultimately build the LGN for those deployed Edge AI systems. So we help companies to focus on just the high value, really interesting pieces of information out in the world.
Thank you, Daniel. I knew this. I knew this topic was going to get complex. I didn't think we were going to dive into neuroscience in the first 5 minutes. So thanks for that introduction. Niv, if I can go to you next. So Niv Hertz is solutions architect at Aporia, where monitoring AI at the edge is a function of what they do. Niv, if you can tell us a little bit about your role and kind of your perspective on what's happening within edge computing.
So, as you laid out, Lee, Aporia is a system for monitoring machine learning models, and as such, we have companies that are coming to us to assist them implementing monitoring for edge devices as well. And we see the growth in applying models and running models on edge devices and the huge need for monitoring those. And previously, in my previous company, I also worked in a cybersecurity startup that focused on IoT and edge devices. So I came from implementing stuff on IoT devices to helping companies implement their monitoring of machine learning models.
Great, thanks, Niv. And yeah, I think we'll hear from IoT more than once today, I imagine. Okay, well let's dive in. So KD Nuggets assures me that 80% of machine learning models never see production. That actually kind of only 20% of the data science output makes it fully into prod, and mainly due to the absence of solid MLOps infrastructure. Now, I can only imagine that number increases when you're trying to deploy at the edge. Daniel, do models even need to run at the edge? You know, what's the advantage of running locally on a smartphone or a laptop versus running via API in the cloud? You know, give me an idea, give me a picture of what are the obstacles for getting models out to the edge.
Sure. I mean, obviously, our business depends on people needing to deploy to the edge. So I would love everyone to say everything needs to be at the edge. It doesn't. For, full transparency. So the best answer to the question, although it's always the worst answer, is it depends. I think that we see like three pretty key concerns of why people deploy to the edge. One is, and is growing even more, is privacy, right? So you can do things at the edge that you don't necessarily have to suck all the data back to a cloud that, for whatever reason. There's latency. So sometimes a decision or an action needs to be taken in even more real time than a 5G or 6G network could ever provide. And the last reason is just general connectivity. So something that Nancy mentioned during her introduction about clearly targeting rural environments is another reason why people definitely want to deploy to the edge. So there are tons of applications that could tick the box of privacy, latency, and connectivity. But for sure, like if you're in any of those spaces, deploying to the edge is a must. Yes, you can always think about that data collection and pulling it back, but if you don't have the connection, you simply can't do it.
Very good. Mike, did you want to ask a question?
Yeah, to that question, is it a continuum? Is it really just, an endpoint, or is it more likely to be the endpoint plus the network edge? Last time I counted, there's probably 5 different definitions of what an edge is. And then, there's stuff moving in between in transit and then up to the cloud. So maybe we want to think about this more as kind of where we are at a moment in time when we're building something versus deploying it. And do we need to have people think about this differently than they might have thought about the way applications are deployed? So I'll throw that over to Niv and see what he thinks.
So that's a very interesting question that you raised. I think that at the end of the day, the definition of edge really is kind of sparse these days, but there are very use cases. There are a lot of use cases where it's very much defined. For example, let's take smart cars, for example, right? It's very much clear that you need to have a machine learning model running on the edge, and the edge is the car, right? Because Daniel raised a very good point about connectivity. If you drive up in the mountains, you don't have connectivity. And if your model is crucial to your braking system, your battery utilization, we know that companies are doing that. So you cannot rely on having cloud connectivity all the time. And so in a lot of cases, what the edge is really not that well defined, but there are many use cases where it really much is, and that's IoT devices, edge devices, smart, everything that is smart these days. I think it's very much clear that where that edge really sits.
If I may jump back in, because maybe to play the clown a little bit, we had a terribly embarrassing conversation with a global cell network provider in our early days. This is maybe 2 or 3 years ago, and for 2 weeks we had this very productive conversation. And only once we actually met them in one of their offices in London, we realized that we were both talking about different edges. And it was rather embarrassing. But from then on, we started to talk about, when we were introducing the concept to people, we started to talk about it very much as, for us, in our business, it's very much the last piece of compute that may be attached to a sensor. And so what we think about it as, whether it's a thermometer or a camera or a LiDAR or whatever it may be, often the last piece of compute that is then attached to a sensor that perceives the outside world that it's operating in, that's what we consider to be an edge device, or the last physical location before it starts to sense and perceive the world. But yeah, you're right, Mike, that different organizations and industries have very different definitions of the word edge.
Daniel, I agree with all of you, but I'm going to add one more thing, because when I look at the edge, it's the place that the data is pulled, which you just said, and acted on. I think is important, right? Because otherwise, you can pull data and gather it, and then eventually take that data on a thumb drive or something and do something with it later. But what we are talking about, at least at Trilogy, and as we look at the automation, the true automation capability, depends on the application, depends on where the edge is. If you're trying to pull data and make a decision and act on it at that point in time, that to me is an easy to understand definition for the edge, and at least that's what we talk to with the rural markets, right? Because they're into, well, what does it do for me? And that's where I think that edge floats around quite a bit. Because if you're trying to run, you can pull data off of sensors and at the end of the day, download it, or once a month, download it, then that's great. You probably don't need the low latency and all of the things that you were talking about a few minutes ago. But if you're going to run a terabyte of drones running over to find an issue, and then you're going to send a robot out to eradicate the problem with a particular part of your field, then that's going to require real-time automation and real-time data.
So let me follow up on that. Do you guys, when you talk to your clients, do they understand that the laws of physics have not been suspended in the age of the cloud, and we have these edge computing scenarios where we're trying to process and analyze data in real time, and there's no magic here. There has to be compute power, there has to be some sort of stateful capability at the edge. But do people understand that, or do they think this is all just magic? I don't know. Nev, what are you hearing from folks?
So I'm going to say 50-50. So I think that today they are aware that there needs to be some sort of computing power on the edge to run AI. And I know that maybe Daniel can speak better about it. There has been significant improvements and utilizations and optimizations to make AI models run on on edge devices. So that magic sort of runs. But what we do see a lot of companies do is that at the end of the day, they have shifted to running models on the edge. They put their models on there, but then they go into the phase where they want to monitor or they want to see that data is working. And they say, okay, I'll just shift everything to the cloud. Mm-hmm. And for the very same reason, and they think that's magic, right? That the cloud can now hold, let's say you have millions of devices that are making 10 predictions per day, per hour. That's over 1 billion predictions per day, and that just would work over the network as a magic, and they can just monitor it, and everything will work as magic. And I think that part is still maybe a bit not well sorted out.
I think these things that we all have in our pockets have done wonderful things for the edge AI industry, and also put a lot of challenges up, right? Because we're so used to this thin piece of rectangle glass in our pockets performing magic, and it always has connectivity, and you click a button and bang, all the pictures have kind of disappeared onto your cloud. So people know the power of, like, I can have compute with me all the time and it can do clever things with connectivity. The problem is that in most industrial applications, a phone is either not rugged enough, or the connectivity isn't the same as in central London or central New York, or the bandwidth and the amount of images that you're creating and collecting are very different to the odd Instagram post, right? So there's been when you say, like, do people get it? I think that they get the power of what's possible, but it's not always necessarily straightforward to understand. Okay, tell us exactly about the type of model you're working with. Let's make sure that the spec of the hardware that you have at the edge is the right spec. What sort of enclosure is it in? What sort of connectivity could it have? How often does that connectivity go in and out? There's a box of questions, right, that you go through when working with a customer.
Well, and candidly, the customer doesn't care, right? They just want it to work.
Well, they do, unless if you tell them that they can run it on a $20 Raspberry Pi, or it's a $36,000 brand new NVIDIA card. They do, and yeah. We see that when we see that, we work with some customers that have 5 deployments, and frankly, if you've got 5 deployments, you really don't need us. But we often work with companies that are in the hundreds of thousands of deployments, and all of a sudden, whether that chip, a little bit like the automotive industry, right? Like, margins are really important. So if all of a sudden you're talking $18 or $22 on a chip, or you're talking $1 per megabyte or $1.50 per megabyte a month, these costs are just like, wow, right? Like, at scale, these costs are astronomical. And one of the things that we work with people is, like, we often reduce people's costs by over 90%. We can come on to maybe how we do that later, but the scales of economy don't always apply to when you're deploying at the edge.
Well, no, that's right, because ultimately the application, whatever you're trying to automate, provide this intelligence, or it has to have an ROI model for the ultimate end user that makes sense. So to your point, as you move down that chain to it, but if I'm sitting there talking to a grower, I would never say, do you understand the laws of physics? Number one, he'd probably laugh at me, because and then he'd put me on a bus back to a big city. But ultimately, it needs to be able to work, right? Sure. If you have a business that has 2 weeks to plant and 2 weeks to harvest and 1 business cycle a year, and how good you are and making your decisions as to where to start both planting and harvesting based on conditions, you don't have time for anything to go wrong.
No, of course not. No.
And so it's those sorts of sensitivities. And I guess if we were looking at surgery or something like that, right, it has to work, right? And I think that a lot of the fear that people have on these things at the end user level are dependent on what you're trying to automate. How important is that to my core business or my core life? And what is the risk reward associated with that? We know, for those of us that are old enough, we grew up with George Jetson. We know that these things can happen or should be able to happen. And we're seeing it. We've been seeing it in the last 20 years with our phones. But this whole new world of taking it into a new level, it's like turning on electricity back in the 30s, right? We don't know where it's going to go and how it's going to go, and obviously economies and reliabilities and functionality. But one thing we haven't spent enough time on is if you don't have the basic connectivity, none of this stuff is going to work. And certainly in areas like manufacturing, rural, et cetera, that connectivity is a challenge. But I also think there's a separation, and be interested in your perspectives. There's the network, right, which may be fiber, and it may be cellular, or it may be public, it may be private, blah blah blah. And then there's the applications and the AI, right? And it's how do you make all of that come together? That I think is one of the enablers or disablers of watching this industry take off.
I think Lee will take us to the next. I think Lee will take us to the next question, but I just wanted to point out that one of our attendees is reminding us that it's called the bleeding edge for a reason. So there you go.
Yeah. Amen. Well, listen, I want to take
this to be my blood.
Who is participant 804? That is hilarious.
I want to take us a little deeper down this path because Nancy raises a good point. The electrification of the 30s or the dot-com boom of the 90s. These had tremendous impact on the workforce and the profile of organizations. So let's just assume for 1 minute that we solve connectivity, that our computer vision models work beautifully at the edge, and we can address all of these challenges. What does that mean for organizations? Niv, you're probably closest to this in terms of the coalface, but what do you think the modern organization is going to have to hire for? And what does that mean for the profile of a big company?
So I think the first thing they have to plan for is the day after the deployment, right? Because you get to the production, everything is working beautifully. But as we all know from AI models and from our past experiences, specifically on edge, by the way, the environment changes all the time, right? You change and you shift, the data changes, your sensors may be starting to break, etc. So I think the very first thing that they need to plan for after they get to a deployed working model is how to update it and how to know when things are starting to change or becoming degrading. So I think that the companies, I know, like from seeing the landscape, I think companies are now aware that they need to do that, but they're not at the point where they're implementing these infrastructures. So I think that awareness is here about that you have to plan ahead for updating and for detection of issues. But I don't think that there's enough knowledge base or enough consolidation and what to do and what not to do once you've deployed a model to production on the edge.
Just to follow up from Niv, I mean, we see that with nearly every one of our customers, right? Like they build an exceptional model that works on training data or works in the environment where they collected that data. And the reason why they work with us is that their CEO or their sales guy has gone, guess what? We've just sold it to Helsinki, or we've just sold it to Baghdad, or we've just sold it to Sydney. Sell it there, go do it there. And the engineers are like, it took us 6 months to collect the data there. Now we need to do the same thing. And the tool that we provide helps them to localize very, very quickly to a changing or even a new environment. But I mean, zooming back out to your question, Lee, I think that my opinion, and maybe it's very, very biased and very kind of rose tinted, I think that we will see phenomenal change in the world, and we will realize the true potential of AI the closer it gets to humankind. And I think that the edge is closer to humankind than Facebook or Amazon's cloud, right? Like it can make a difference, of course it can, and it does more important things than optimizing which pair of trainers you see when you're browsing Twitter. But the real impact, the true impact on millions and millions of people is when the AI is making things safer in real time, or it's making more food in real time, right? And all of these things are happening at the edge. So I think we're at the we've thrown around the word AI a lot for 10 years and probably even longer. I think we've started to see some economic gains in people that say they do AI for the last 5 years, but I think we'll see fundamental human changes in the next 10 years because of edge AI.
I think
Daniel, you touched.
Sorry, I was going to say, I think we're also going to see the hyperscalers change as they're going to have to push their clouds out to the edge, right? Because they just are not going to be able to process all of that in New York and Chicago. So all of that, it's an evolutionary activity that probably will take off, faster than people can keep up with when the killer apps start landing.
I'm optimistic like you, Nancy and Daniel. I think that we stand to benefit from the explosion at the edge, but there are some shadows cast here. So already we see challenges with differential privacy with kind of standard machine learning. And if we extend that to the edge, then preserving privacy, security becomes even harder. Niv, what do you think we need to prepare for? What does our good governance look like when we're setting up our edge deployments?
So I think that the shift to edge to solve the privacy issues was a very good direction, right? We needed to shift to the edge so we don't share the data and we keep the data stored in one location and the data never leaves your device. Now, the next thing that we talked about is how we update, how we know when things are starting to break, and how we control that system, because eventually we put some system at the edge which belongs to client, and we want to make sure that it's working and functioning the way it's supposed to, and that it's doing what it's supposed to, right? And I think that, again, this part doesn't have a very solid solution yet. People, we need to find a way to also include the monitoring and the testing or some sort of metric that lets you know that your machine learning models are functioning properly, that your system is working without having to send that data, that private data, to the cloud. So I think this is the next step that we need to take, is be able to produce metrics or any other thing that would, again, be able to tell us that everything is working properly, or if it's not working properly, what is the problem, without breaking that privacy issue.
So isn't the, what we're seeing is the creation of a private network on site to be able to contain as much of that data locally as possible, right? So that the edge is right there as much as you can. Because I know that people are paranoid about their data, and obviously there's an opportunity, somebody's going to figure out great opportunities for the user to monetize their data rather than just Facebook and Instagram. But both the privacy and the security of the data is going to be really key.
Is there a set of... Sorry.
I take a very different. I think you have to secure like the boxes themselves. So we work with a technology company that installs onto big farms across Europe, and they're very conscious of like they put these boxes under lock and key, right? Like they're important boxes. But there's a thought process that data used to be very much the new oil, right? Like it was very much let's collect as much possible data as possible, loads and loads and loads and loads of it. But actually, there is a sense of if at the edge you're able to run the inference that you need, so you're able to say this is a cow or this is a chicken and I can count it, or this is 10,000 faces went through Terminal 4 in Heathrow in the last hour, or whatever it may be. You can delete the data. You can delete the data immediately the moment the inference is run on it. The only data that's really important to you is the pieces of data that the model has failed on. And so I feel like I'm keep plugging LGen, and I really don't mean to, but in real time, we're able to understand which piece of information that model has failed on. And that's just that small piece of the pixel that we send back to the system owner to say, hey, the inference failed on this, right? Like, can you label that for me or tell me what it is? But the rest of it can be deleted. And I think that in the build process of your model, there is a sense of the amount of data that you're collecting versus deleting is quite wide. But as you get better and better and better, the amount of data that you need to store and label and process actually diminishes. And so I would argue that the more edge and the better edge your model is, the less data there should be.
I think that's true. That's true of model. Sorry, Mike. Did you want to go?
Yeah, if that's the case, then do we need a set of best practices to be defined for addressing privacy, security, even the drift of the models for how we're going to manage this stuff? Because it seems like everywhere else we've gone with IT, we always seem to default to some sort of best practice that at least gives people a foundation to work with. But do we have that for AI?
We don't, but we don't at all. But I guess you could argue that a facial recognition system in Shanghai airport versus a camera that monitors the weight of pigs on a farm deserves very different privacy conditions. So I think saying let's set a standard for AI is like super tough, right? Like I'm not saying it's right or wrong. I'm just saying that becomes very difficult. So maybe it's a standard of vision systems powered by AI that ingest human faces. Maybe that's where you say, okay, this is a standard now that we have to set for that. I don't know the answer, by the way. I'm just saying that there might have to be some like in military, there's some like security clearances, right? And so depending on the sensitivity of data, there's got various different bits around it potentially.
Yeah, and value of what's important is candidly in the eye of the beholder, right? Because because the face, I mean, obviously we want to protect someone from blowing up Heathrow Airport, but the guy who is developing a varietal of seed for bear, that data is awfully important to them. So it becomes in the eye of the beholder. Yeah. I'm seeing a lot of comments in the chat around, you know, the role of 5G and the role of private networks, and I would just say for our business, we see pushing the edge out to, you know, the manufacturing facility or out to the farm or out to the hospital, and then wherever possible, setting up a private cloud there so that you can do as much, not all, but as much locally as possible. And I'm sure the rest of you guys want to comment on that, but that seems to be the team, the participants are asking us to talk about that.
Yeah, I saw a comment about the 5G and 4G, and it's absolutely correct that we don't even have 4G everywhere, let alone 5G. And we have this diagram that shows if camera technology never moved on from when there was the first camera phone ever made, we would never have needed to do 4G, right? so this idea of network improvement solving this problem is a fallacy, because as we move from 5G to 6G, we'll have much higher resolution cameras that pick up much higher bandwidth of data. And these two things, almost since the beginning of time, have trended upwards together. Sometimes, they're kind of fighting for pace, but by and large, our expectation, especially, by the way, as the general public becomes much more au fait with modern technology, again, because of the iPhones in our pockets, you start to think, well, 5G, what's next? And so people build applications and hardware to kind of take advantage of the next level of G, as it were. So, yes.
Well, don't you think the reality is you're going to have to, it's like every form of technology. You're going to have to work with legacy networks and future networks, and how you can move and push this as fast as possible, depends on the value creation and the capability for that to be economically viable. I mean, I know in the United States we're spending $70+ billion to put connectivity out in rural America, but it isn't just rural America that has these challenges, or rural city, these cities, because I sit in one of the best neighborhoods in Dallas, Texas, and have the poorest cell coverage possible, as well as internet. So
one of our attendees is suggesting that perhaps 5G doesn't work as well as advertised, so you need to plan accordingly, right?
Yeah, but your mileage may vary.
Yeah, don't worry about it.
Here. So I want to dig into something a little bit here. So in the latter part of the last decade, we saw that kind of data science was very much focused on your model accuracy. It was all about the model. Could I tune my model, my weights and biases to a point where I was managing recall and precision. It was all about the model. The start of this decade was starting to realize that actually it's not about the model, stupid. It's more about kind of data and garbage in is garbage out. And a data-centric world is actually more important than one that's focused on model accuracy at the be-all and end-all. So we've seen kind of the emergence of MLOps, which is more than just a portmanteau of machine learning and DevOps. It's a whole kind of credo, an ideology, an approach to building good infrastructure. What do we need for Edge from an infrastructure point of view that is going to allow us to take the next step forward? Daniel, you touched upon it when you talked about telcos and coverage. But what else is required here from good practice to get Edge a reality?
I think Niv highlighted the idea of we call it internally, we call it model recency. And this idea of like when you build a model and you deploy it over time, it degrades, and it degrades because of an environmental change, sensor damage, model drift, what you name it. And so there is within the DevOps MLOps kind of space, we certainly felt the need, in order to deliver well enough on AI, you had to continually update it. So you need the initial model. It has to be great, and you're absolutely right. Like model versus data in, get data out is all very relevant still. But it's no good building a model, deploying it, and say it's not like software, right? Like if you write a Windows 95 Microsoft Word application, you can dust your hands off, and as long as you don't change the computer or the OS, 10 years later, it might take a long time to boot up, but it will boot up and it will work. You can still type a letter on that computer. AI just does not work the same. right? Like because the environment that is now perceiving is so drastically different, it will fail, and it will fail miserably. So the ability to constantly stay up to date and stay relevant, stay recent with your model is key. And we actually see, we work with a few a few companies in the defense space, and they talk a lot, and I think it's a really interesting topic, about digital trust in a system to deliver. And it's quite fascinating about digital trust, because there is this sense of, does the human believe what the output of the model is saying? Nancy mentioned it earlier, like a lot of farmers go on their gut, right? They just know because they've been doing it for 50 years, and their father before them, and their father before them, they know exactly when to farm and to seed. So digital trust is interesting. And one way that we think about digital trust is model recency. And the reason why we say that is because if it was trained on data 6 months ago, potentially your enemy has worked out how to confuse a system. Potentially the broccoli plant has evolved. Potentially a new car has been released that confuses sensors. All of these things happen. And that's what degrades the performance of a model. Whereas if you can say to a customer, hey, like as of 48 hours ago, your model was retrained on the latest data set, the trust that you get off the back of that grows. And so in summary, I guess what I'm saying is that model recency is key, can address a lot of concerns, and therefore the tooling and the knowledge and the expertise of how you constantly stay on top of this model retraining without exploding your costs is, we believe, obviously bias, is really important.
If that's the case, are we really talking about continuous training then? And today we have training that sits up in the cloud. So is the training going to move to the edge too to make all that happen? Or how does that kind of, what are the mechanics of making that work?
I mean, I don't want to take over. Someone else might have a thought on it, but if I may say, I think that I hate the answer, but it depends, right? So if you've got a really high-powered edge GPU and the model that's operating on it only takes up 20% of that, the headroom, if you like, you can absolutely use your network of edge devices to use the edge to also train as well as run inference. If it's more important for you as a business to keep the costs of the edge box low, or maybe even the power consumption of that edge box low, then actually you don't want to do that. You want to optimize for it just doing its job, and then you'll keep the retraining in the cloud. So I see it as a bit of a seesaw and a balance. You can do it. I'm not 100% sure if everyone will want to do that.
So I have a question for you then. Is that assuming that you're doing that for the enterprise, or are you talking about the application developer provider, right? Because who's deploying AI, there are multiple levels of who's deploying the AI.
Are you talking about LGen specifically, or
No, just generically? I'm like, if I'm it sounded like that's very specific to an enterprise, right? To an enterprise network that's running a series of applications on AI, and what the risk of it not being current is to that organization depends on the investment level to keep it current. But if I'm over here and I'm the application developer of drones that are doing X and delivering this, then if I'm keeping it updated more currently, would I, and this is a question, I don't know the answer, I'm asking you, would that then be able to feed through my whole network of wherever I have that deployed?
I think I get the question, so definitely forgive me if I haven't grasped it. But
you wouldn't be the first person to not understand me trying to ask a technical question.
So I think that, like, if you're the application developer of a drone that can detect, that can go along a vineyard and try and count the amount of grapes, right, that are being produced, is maybe a decent application. you may have built a vision system on that drone that just does this. Now, if you just have one drone and that is your edge, and you go and fly it on that crop field and you give that person that number, for sure, firstly, you're not even really deploying the AI at scale. You're just kind of connecting that drone to your laptop, putting the model on it, and off you go. Or dare I say, you're probably just making the video on the drone and plugging it into your laptop and running the inference on your laptop or the cloud. So I think it differs on the scale of your operation. You mentioned enterprise. For sure, I think if you've got 10,000 boxes attached to traffic light cameras in a suburban environment, then you're going to want to be able to manage that remotely and understand how they're performing remotely. I think they're different scales, and you'd probably need different tools for different. Unless I've totally misunderstood. I hope
okay, so close, but so I was on a panel a few weeks ago with an Israeli company where they have these drones that fly through orchards for pitted fruits like apples. They've got 4 drones and 8 cameras per drone on a device with a little suction cup that can in real time decide the weight and the color and whether or not it's ready to be picked. And then the little suction cup picks it. Boom. Great. So I update that, yes. But let's assume, I'm assuming I flash forward and this company has 10,000 of these out in the network, and they're all going at the same time because it's harvest season. What I'm asking you is, if you go back to your how current do you keep that technology, would they not be able to, would the onus not be on the application provider to keep that technology up to date so that it's deployed in mass across their whole, anywhere their software and capability is deployed?
Yeah, absolutely. But I think it sounds certainly in that use case that the application is definitely using AI to understand what to pick and what not. So it's responsible for staying up to date. Let's say that an orchard is an interesting one, but let's say that from this year to next year, the farmer used a different chemical to fertilize the ground, and that had an impact on the slight shade of the apple. So that same guy comes back with the same drone next year and flies it up and down. You could argue, and again, maybe an orchard is a bad example, but you could argue that slight different tone in apple means that model no longer performs quite as well. So what you would need to do is you would need to very, very, very quickly, because that, as you said, that's a window to harvest those apples. You would need to very quickly be able to identify the slight change in the apple or the environment or whatever, and say, actually, this is now what we're picking, not this. And so that's what I mean by recency, is that just before, you don't want to go pick a bunch of apples that are rotten or are not ripe. Because
so that's, you verified exactly what I was asking you. That's when these application developers are going to have to be able to make those sorts of real-time changes in their model. I'm sure they likely know it, but that's, again, one of the things that we're all going to have to come to grapple with as we learn that, because, as someone's saying here, this feedback loop depends on the user case, and that's absolutely absolutely true, which plays back to your earlier question of how do you regulate or put standards on all of this when there may be 10 buckets of what these applications look like, but they're all going to have different combinations and permutations of new and wonderfulness in this.
To Mike's point earlier, like there's a company that they were looking at fashion. They were monitoring fashion trends, and they're working in Australia and in Europe. And their vision systems picked up that a T-shirt that was sold by an organization was an unintended, unconsequented pixel hack on that system. Instead of counting the T-shirt, it counted another face right on the T-shirt. If you take the normal approach of, well, we'll check how our AI is working every 6 months, you could have a real problem on your hands by the time you readdress it. And that means angry customers, like disappointing performance, and ultimately a lack of trust in the AI. However, if you're constantly monitoring for where that model may have been confused, the idea is that you can identify the uncertainty when that T-shirt is first sold in Australia, and before it's ever even sold in Germany, you've picked up on the anomaly, you've retrained the model, and you've redeployed it to all of your cameras. And within that day, within that window, it's no longer a problem. And so staying on top of it can mean a consistent level of great performance.
Hey, I want to bring.
I think we're on Niv's turf here.
Let's bring Niv back in here because, and the question is, at least from my perspective, is do developers get this? Because when I talk to people, there's a data science team on the left-hand side, and they might as well be from Venus, and then there's a bunch of developers from Mars on the other side, and how those two groups come together to accomplish anything is often semi-miraculous. So, do we have the skills and the knowledge and the expertise to execute the stuff that Daniel and Nancy are talking about?
So, do we have the skills? The answer is probably yes, well, definitely yes. But you're right. The problem is that sometimes it's different people who are responsible for different things. And when it comes to monitoring and keeping our application up to date, this responsibility hasn't been properly defined. Is it the data science team's responsibility, or is it the ML engineers, or is it just are people who are just in charge of level 1 support team that are supposed to detect these issues? It hasn't been properly defined, and I think that each of those teams has a different requirement as to how you want to see that data, what kind of reports you want to get. Is it a business? Do I want to tie it to a business use case, or do I want to tie it to a machine learning metric like accuracy, etc.? So I think that this the problem or the gap that we need to cover, it's not a problem, but it's something. It's a step that we need to take a step forward. Is making sure that we know who's responsible for this monitoring, for this updating, have clear definitions of what does it mean to have AI included in your product, right? Because a product keeps on living, right? And the data scientist may just look at it as a one-off, one-time, hey, I developed a model, it's working great in training, that's it, my job is done, I'm moving to the next project. So no, that's a system that is live, that needs to continuously get updates, like Daniel very much explained why. So the gap is defining who is responsible and how to do that, how to keep it updated, how to trigger alerts when it's not updated, etc.
So where so many people, people are they're pretty cognizant now that they have to worry about security and privacy. This sounds like it needs to be an area that needs socialization, exposure, because everybody's going to come at it a different way, but people probably don't even recognize that it's a challenge yet. Is that fair?
Mm-hmm. I would say it's fair. I also think, one wag once said to me, the trouble with AI in general is it's one thing to be wrong, it's another thing to be wrong at scale. And the perspective here is that we don't really have the mechanisms in place to kind of make sure that when things drift or whatever the issue is, it somehow or other becomes automatically contained. And I can't help but wonder if AI might cure AI. I mean, eventually, am I going to create models to track drift and privacy violations, and then I got to find something else that keeps track of that? But so are we going to build layers upon layers of things here? I don't know, but curious to what in your perspective is how automated can automated get?
Yeah, I think governance.
You just turn it over to Daniel and he sorts it all out for you.
All right.
Listen, before we hear that question, Sorry.
Before we close, I wanted everyone to dust off their crystal balls. It's 2032. Trilogy, Aporia, and LGN have IPO'd and exited for multiples, and we're all looking back on successful careers. Edge computing has played a fundamental part of our success. Tell me, what was the tipping point? What was the moment? What was the difference, the milestone that made the difference? And Daniel, I'm going to pick on you first.
Oh, I think you said it in your intro around healthcare and ag tech. I mean, ag tech is a sector that we are deeply involved in. Healthcare is not a sector we're involved in, so I picked those to balance. But I think that they're both sectors that humans will be able to look at and say, if it wasn't for an AI application in that industry at this moment in time, we could have been wiped off the face of the planet. I mean, what people's opinion on COVID aside, like people being able to build a new vaccine at an infinitely quicker rate than the last time we needed to deploy a global vaccine was massive, right? Like, and I think people started to realize, like, wow, okay, these kind of science nerds aren't all about running ads on Facebook. There's some real impact here. And for me, being able to feed the next billion or feed the existing billion and stay relevant in healthcare and these connected devices and saving our lives, for me, I tie it to the emotion of like, wow, okay, that really changed the game.
Yep. Yeah, good answer. Niv, what about you? What's the shape of Aporia 2032 and what made the difference?
So I'm going to go with the more boring answer. So I think, like, to me, I feel that the shift that would shift things towards running more on the edge and building confidence in that is the smart cars. So the automatic cars that are running without drivers. I think like that's something that we've been hyped for years, and it is yet to come. And we've all been waiting for that. We've all thought, hey, 2022 we'll have automatic vehicles. None of us will have to drive. And I think that this would like really signify the date and time that we're really prepared, because again, autonomous vehicles have a lot at stake, right? You have people's lives at hands. It's very risky. You have AI models driving you around and literally controlling your life. So when we see that running live and we come to trust that, I think that will be the turning point that will get us all running AI on edge and thinking, hey, we can actually do these applications, trust them, and they just work.
Wow. Yeah. So Niv says, keep your Tesla shares. Nancy, what about you? What do you reflect on?
Well, so by 2032, we will have needed to make a massive impact on the amount of food grown, right, and exported. So I would look back and say, at the point where growers had X level of automation, and to do that is likely going to take some of the government getting the connectivity deployed out to these areas. That's happening, and likely the adoption from some of the larger ag retailers, Land O'Lakes, et cetera, that say we need to automate not just the very large farms, but the 2 million farms, that we have domestically. And so you're going to have to provide X data, or we're going to have to be able to drive this. And that's going to drive a sea change, right? Got a chicken and the egg, though. They're testing, they're evaluating, they're doing bits and pieces. All of this is happening. The connectivity problems have to get solved. Some level of edge platform, hopefully the trilogies, and the ability to have a marketplace to drive those.
Hey guys, we gotta let Cody take us out because the hour is up, and it's been a fascinating and awesome conversation. My answer to that question, of course, is that my avatar will be conducting these interviews while I'm sitting on the beach. So that's my prediction.
Well, all right, Mike, and we can only hope that maybe one day I'll have an avatar to close us out.
Well,
So,
thanks for inviting us.
of course, to Mike, Lee, Niv, Daniel, and Nancy, thank you all so much for joining us and for leading us through this past hour of intellectual conversation. I know I really took a lot away from this myself. So I would like to remind all of our attendees that this session was recorded. So following this program, you'll receive a link to access this recording on demand, or you can find it living on the DevOps website at devops.com/webinars, and be sure to look in the on-demand section. We do still have those 4 $25 Amazon gift cards to give away. So our winners are Sandra S., Perry B., Christopher C., and Raghu G. So to our 4 winners, congratulations. Keep an eye on your email inbox to claim that gift card. But if you don't happen to see that email, do check your spam folder. So I'd also like to thank the AI Infrastructure Alliance for sponsoring today's program. And to everyone who attended, we really appreciate you spending the last 60 minutes with us. We value your time, and we also value your feedback. So as soon as we close out, you will see a pop-up of a survey on your screen, and we'd really like your participation there. Let us know how we can improve on our future programs, or let us know what you liked about today's program. Other than that, I think we are ready to close out. So everyone have a great rest of your day, and we hope to see you all at a future Techstrong Learning program. To our panel, thank you once again.
All right. Bye-bye.
Hi.
Bye-bye.